Welcome to the Laboratory, a video series brought to you by Miracles Innovation Labs.
Hi and welcome to the Laboratory video series. I'm Maunika Chirukuri, working as lead researcher for Data, Cognitive and RPA at Miracles Software Systems. Today I'm going to talk about how we can detect human emotions through edge devices using machine learning and IoT. Here is our agenda for today. First, I'm going to explain about edge computing and how machine learning can be applied on edge devices. And then I'll talk about custom vision and edge devices like CPUs, TPUs, and GPUs. I will also explain about OpenCV and TensorFlow Lite. Later, I'll show you the architecture that we followed to build this use case, and then a live demo of the application. An edge device is like an entry point to core network. It controls data flow at boundary between two networks. In general, IoT data is collected and transmitted either to a cloud or a data center where it will be processed and analyzed. Instead, we can process the data right where it has been generated. So edge computing means processing the data generated by edge devices or these IoT devices near the edge of the network. So before sending all the data to the cloud, we can apply machine learning algorithms right at the edge, which allows smart applications to respond to data quickly and get results on the fly. Using machine learning on edge has a lot of advantages. Like since we're going to apply machine learning models on the edge, the processing takes place locally. As the data is analyzed at the local device level and not in a distant data center or a cloud, the application speed will be better, and it also provides better security to the data. Due to the smaller operational and data management expenses of local edge devices, the cost will also be reduced. And since we're going to send only the not ordinary data to the cloud, it reduces network traffic problems. It provides faster predictions, which enables better decision making for critical applications. Custom Vision is a cognitive service provided by Microsoft for image recognition. Through Custom Vision, you can create a model in 3 simple steps. All you have to do is collect an image dataset and upload those images to Custom Vision with relatable labels, and then train the model with those images. So once the model training is done, it will show you how much accurate the built model is. You can then test the model with the new images which you have not used for training, and the output will be displayed right on the screen. So if the model doesn't give the output that you desire, or the accuracy that you need for your use case is not that much, you can always retrain the model. So when you have the final model ready, you can export it and use it in your in any of your applications, like a web application or in a mobile application. So another great thing about this service is that we can use the exported model offline as well. So for training any machine learning model, the processing time is dependent on the size of the data set and also its input parameters. When the data set gets larger, processing it might take from hours to weeks. So in order to avoid this processing lag, new processing units have been designed. Traditional CPUs only have a handful of cores. So when you train a model with a CPU, it will take a lot of time, and the processing will be done in a sequential way. So when you take a GPU, it has thousands of logical cores through which simple operations can be processed in parallel. So training a model with GPU is faster when compared to a CPU and also provides better throughput. TPU, on the other hand, is developed by Google specifically for machine learning and tailored for TensorFlow. It is 10 times faster than a GPU. However, they are more focused on executing predictions after training. OpenCV is a cross-platform library for developing computer vision applications such as image processing, video analysis. It has C, C++, Python, and Java interfaces, so we can use any of these languages to build a model. It provides computational efficiency, so it is very well suited for real-time applications. TensorFlow Lite is used to provide machine learning inference on small devices, so which are resource constraints such as mobiles or embedded devices. So when we want to run a machine learning model on small device, we can use TensorFlow Lite Converter, which basically optimizes the model and it also makes the model work faster. Here is the architecture of our application. We have trained a machine learning model with an image dataset consisting of human faces with different emotions like happy, sad, angry, and all. We have trained this model on a GPU and stored the model file, which is nothing but the .pb file, in network storage. Then we installed that model file in Raspberry Pi and created a web application for it. We created the web application with Python. So we have also connected a webcam to the edge device as well. So when a person appears in front of the camera, which is connected to the RPi, it will identify whether that person is male or female, and also shows the emotion of that person. So whether they are angry, sad, or happy. So we have also used historic data and showcased some graphs as well on the web page, which I'll show you in a while. In any application, if you're not happy with the precision percentage of the model, or if there comes a need to retrain the model, maybe it's because of to increase the accuracy or to adding some more features, the model should be automatically updated in the application to make end result accurate. So in our use case, we have used Eclipse Paho to make it possible. So when the model is retrained and updated in network storage, a message will be published to Paho about the model. So the edge device, in our case the Raspberry Pi, keeps listening in Eclipse Paho. So when it reads the message like new version of the model is available, it will go to the network storage and fetches the latest model file. So every time a model is retrained and updated in network storage, it is installed in Raspberry Pi, making the application updated as well. Let's look at the application and see how it works. So here is the dashboard of our application. We have connected a camera module to Raspberry Pi. So the live feed from there will appear here on the screen. So whenever a person or a number of persons appear in front of the camera, their facial expressions will be displayed over here, whether that person is happy, angry, or sad. That's in real time. And we've also used some historical data, like since the start of this application, it will calculate how many number of males or how many number of females have appeared in front of the camera. For example, 25 number of males have appeared in front of the camera since this application has started, and 9 females have appeared in front of this camera. So this is based on the real time and the historical data. Here you can see the number of males or females at a point of time in front of the camera right now. So as of now, there are no people standing in front of the camera, so both the values are 0. Here in this graph, we're showcasing the expressions of persons. So again, this is the historical data, so it will tell the number of happy faces that appeared in front of the camera, or the number of surprised faces, or the number of angry faces, like that. So let us see what happens if a person appears in front of the camera. So here you can see there are 2 persons that are standing in front of the camera. It's showing that woman happy and then man happy expressions. And as well, you can see here that the count of the persons in front of the camera is displayed over here. As of now, there is 1 person, 1 male and 1 female, so it's showcasing that. And if they change the expressions, the application is able to showcase their expression as well, whether they're angry or neutral or happy or surprised. That will be reflected over here. And the same will be reflected over here as well. So here you can see that based on the time, it's showing that the person is surprised or the person is in a happy or neutral state. Here you can see that the 2 persons are in happy state, like that. Thank you.
Thank you for watching The Laboratory, a video series brought to you by Miracles Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.